So guys, what you have here is a student carries out, an economic student wants to find out whether the length of time people spend in education affects the income they earn. The students carry out a small study. 15 adults are asked to state their annual income and the number of years they spend in full-time education. The data are given in the table below, as well as a partially. Now, it means it's not fully complete. Now, why is it not fully complete? The last 5 rows have not been added. So, what do we have? 70 and 60. So, 70 across and 60 up is that one there. We have 70 and 30. So, where's 70 and 30, lads? 70 and 30 is located here. Then we have 70 and 58, which is just below 70 and 60. And then we have 70 and 65, which is located here. And finally, 19 and 70, which is 19 across and 70 up. Now, for those of you that were missing yesterday, you could find the average of both of them, couldn't you? If you wanted. What happened if you found the average of both of them? You'd know where the line of best fit would go, wouldn't you? Now, is there any outliers? Ones that are ridiculously out of the general trend? I see the general trend like that. Do you guys? Yeah. Something like that. The longer you spend in education, generally the larger your earnings. But I see 2 guys who are way out of proportion. These 2 guys here, the 2 yellow ones. So an example is this guy spent 17 years in education and makes 30 grand. So that's a lot of time to spend in education for 30 grand. And then the opposite is true. 11 years and this guy's on 65 grand. So that means that guy is actually doing really well for himself. It could be on whatever field you're in. Okay, depends on what you specialize in. Okay. Now, what can you conclude from the scatter plot? The higher the more time spent in education, the more money you should generally earn per year. So there's 2 problems that could be associated with carrying out such a study. Do people ever really want to tell you how much they make? People are quite secretive about that because some people are embarrassed. Like, let's say the person spent 17 years in education. They're very likely to tell you they only make 30 then, if you get what I'm saying. So then some people can be offended by asking about their education as well. Like, do you think I'm stupid? Stuff like that, okay? So that can happen as well. All right, Peter Graph's already done. Do you not see that? All right, question 2. Did I give you question 2? No. I didn't give you 2. Oh, did I? I'll do 5, so leave 3 alone. Hopefully 3 was easy. Alright, this one here. We have altitude above sea level. We have altitude above sea level and the temperature. Everybody see that? Altitude above sea level and the temperature. Illustrate the data on a scatter diagram. There you go. All these points are drawn. Now, do you notice the way you don't have to go back to 0, 0? Everybody see that? It doesn't have to be done. Okay? So you can just start off at 6. Now, you draw your points. What you see is the general trend with this. The higher the altitude, what happens? The higher the altitude, the lower the temperature. Is that alright? So, what we're going to do is we're going to try and... Can somebody do me a favour? Let's all do this together. Max, and this side of the room, can you get me the average of the yellow parts? This side of the room, I want the average of the blue parts. Okay? I want the average of the yellow and the average of the blue, please. So, the average temperature is 15.28 when this is still recording. And the altitude, yes? 1,000. Now, what we're going to do is we're going to make a point here. 1,215.28. So whereas 1,200 is here, 15.28 is 15 and then 0.2. So the line of best fit will have to travel through that blue point. Do you get what I'm saying? So it's a great way of getting a line of best fit. Does that make sense? You always make an average then. Yeah, I'd always put the average of both of them in, and I would always draw on my line of best fit through it. Now this line of best fit helps me to estimate the 2 answers here. An altitude of 1,000, what do you expect? Now where is 1,000? It's not halfway in between, is it? Because 1,500 would be halfway in between. So just below halfway, roughly 1,000. Where does it hit? Go up and across. And what's our answer for altitude of 1,000 meters? 16.5. Are we expecting 2,400 to be colder or warmer? Colder. Actually, guys, look at this. 2,400 will be located. Is everybody happy that's 2,400? Right, and I'll continue the graph downwards, like so. Now, where do you think 2,400 is intercepting? Go across. What degrees do you think that'll be? Halfway between 0 and 6. Yeah, around 3 degrees. Actually, do you know what? There's a mistake in this question. I'll cover the mistake now. See the way that's 9, that's 11, and that's 7? It's actually 1 below 6. The 0 doesn't matter. There's a mistake in their solutions. Okay, that'd actually be 5 degrees. Is that okay? That's the danger in doing that. Okay? Okay, we're all good? Alright. So that's 2 and 5. Oh, sorry, that is 1 and 5. And we gave us nothing else, did we? 2. Ah, yeah, we don't need to do 2. We're grand.